This video tutorial I will explain what are microservices. Here you can see the client, and the client can be app from mobile device or web browser from laptop. The client send request to API gateway, and API gateway, based on the request, it will forward to either microservice A or microservice B. And microservice A has dedicated database, and microservice B has a dedicated database. Microservices are loosely coupled. Each microservice handles a dedicated function inside a large scale application. And microservices architecture enables large teams to build scalable application that are composed of many loosely coupled services. Here you can see shopping cart microservice, and it is connected to shopping cart database. And here you can see billing microservice, it is connected to billing database. Here you can see user microservice, and it is connected to user database. And shopping cart microservice is responsible for adding item to the cart, removing item from the cart. And billing microservice is responsible for billing the items in the cart. And user microservice is responsible for creating user, deleting user, updating user, etc. And here you can see the client send request to the API gateway. And if request is related to billing, then API gateway forward the request to billing microservice. If the request is related to user management, then API gateway forward the request to user microservice. If the request is related to adding item or removing item from the cart, then API gateway forward request to the shopping cart microservice. Here you can see shopping cart microservice. Here you can see billing microservice. If shopping cart microservice wants to talk to billing microservice, then it can use RPC, which is nothing but remote procedure call, or event streaming, or message brokers like Kafka, RabbitMQ, etc. And RPC provides faster response, and event streaming provides better isolation between services, but it takes longer to process. Microservices can be independently deployed. Each microservice is small and easier to identify the issues, and it has a smaller impact. This gives the operators peace of mind and confidence to deploy often. And microservices provide more flexibility to scale up individual microservices independently. And this operational flexibility is invaluable. If shopping cart related functionalities, billing related functionalities, and user related functionalities are in the same application, then it is called monolithic application. And this monolithic application connected to database, and this database contains the tables related to shopping cart, tables related to billing, and tables related to user. Then this database is called monolithic database. And here you can see the client communicates to this monolithic application, and this monolithic application communicates to this monolithic database. Suppose we want to split monolithic application into multiple microservices, then what we can do is, for shopping cart related functionalities, we can create shopping cart microservice. For billing related functionalities, we can create billing microservice. For user related functionalities, we can create user microservice. And also, we have to split this monolithic database into multiple databases like this. Shopping cart related table will go to shopping cart database, and billing related tables will go to billing database, and user related tables will go to user database. And this shopping cart database will be accessed only by shopping cart microservice. and billing database will be only accessed by billing microservice, and this user database will be only accessed by user microservice. Well architected microservices practice strong information hiding. This means breaking up monolithic database into its logical components, and each logical component well hidden inside its corresponding microservice. In this example, this is one logical component, and this is one logical component, and this is one logical component. And by logical component, it could mean separate schema within the database cluster, or it can be a entirely separate physical database. One big drawback of microservices is breaking up the database. And by breaking up the database into separate logical units, the database can no longer maintain foreign key relationships and enforce referential integrity between these logical units. For example, in case of monolithic database, user table and billing table will be in the same database. So we can establish a foreign key relationship between user table and billing table. But in case of microservices, user table will be in the user database and billing table will be in the billing database. So we cannot establish foreign key relationship like monolithic database. So the burden of maintaining data integrity is now moved into the application layer. So the application layer has to take care of data integrity. Here you can see the API gateway. Client send request to the API gateway, and based on the incoming request, the API gateway route the request to relevant microservices. Suppose say the incoming request is related to shopping cart, then API gateway route the request to shopping cart microservice. If the incoming request is related to billing, then API gateway route the request to billing microservice. And here you can see identity provider service. And API gateway relies on identity provider service to handle authentication and put authorization of each request which is coming through the API gateway. Here you can see service registry and discovery service. The client send request to API gateway. Once API gateway receives the incoming request, based on the incoming request, it will consult the service registry and discovery service to locate the microservice. Once API gateway locate the microservice using service registry and discovery service, it will route the request to the particular microservice. And these microservices register with service registry and discover the location of other microservices through discovery service. There are other useful components in microservice architecture like monitoring and alerting, DevOps tooling for deployment, and troubleshooting, for example. Microservices cost money to build and operate, and microservices really only make sense for large teams. For large teams, it enables team independence. Each microservice can be independently maintained by dedicated team. For example, shopping cart microservice can be developed and maintained by one team, and billing microservice can be developed and maintained by another team, and user microservice can be developed and maintained by another team. And in a well designed microservice architecture, these independent teams can move fast, and impact of failures is well contained, and each microservice could be independently designed, deployed, and scaled. Microservices implementation is usually a not good fit for small startup company. What startup company can do is to design each function in the application with a well defined interface. One day, if the business and teams are growing fast, then microservices architecture starts to make sense. It would be more manageable to migrate. You can get Java source code link for each video from the description section of the video. And here you can see the video, and to see the description, click on this more, and here you can see the description, and here you can see the links, and click on these links to get the Java source code.